Ask a chatbot what the capital of France is, and it answers Paris. It feels like it looked something up, a search, a database, a fact off a shelf. Here is the strange truth. Nothing was looked up. There is no database inside, no encyclopedia, no shelf. The machine that answered does exactly one thing, over and over. And by the end of this video, you will understand how that single thing produces something that feels like it knows the world. The thing in the box is called a large language model. Its one job, its only job, is this. Given some text, guess what comes next. That is it. Feed it the words, the capital of France is, and in that moment it does not search, does not look anything up, does not consult a map. It calculates for every possible next word it knows how likely that word is to come next. Paris scores enormously high. Lyon scores low. Banana scores almost 0. Then it picks from the top of that list and writes one word. Now, the part that surprises almost everyone. It does not write the whole answer. It writes one word, then stops. Then it takes everything, your question plus the word it just produced, and feeds it all back into itself as a brand new input. And it guesses again. One more word. Again. And again. Every sentence is built one guess at a time, each guess informed by every word before it, which means something genuinely odd. When the model writes the first word of a paragraph, it has not committed to how that paragraph ends. The ending does not exist yet. At this point, you might be thinking the obvious thing. That is just autocomplete. My phone does that. And you would be right, it is the same idea. So here is the real question of this video, and I want you to actually pause and think about it. Your phone predicts the next word and suggests, okay, thanks, see you soon. This thing predicts the next word and writes working software, explains medical results, drafts legal arguments. Same trick. What accounts for the difference? The answer is the most beautiful idea in modern artificial intelligence. It is not that the model was taught facts. It is what predicting well demands of you. Think about what it takes to be excellent at guessing the next word, not on a phone, but across the entire internet. Imagine the final page of a murder mystery, and the text reads, "The murderer was revealed to be," and a blank waiting to be filled. To predict that next word, grammar is useless. You must have tracked the whole plot, the alibis, the clues, and who was in the room. And notice what your own brain just did with that blank. You predicted. And to predict, you had to understand. That is the trick. Prediction here is impossible without comprehension. Now multiply that. To predict the next line of a program, you must learn that programming language. To predict the end of a proof, you must learn logic. To predict how a doctor finishes a sentence, you must absorb medicine. To predict a poem, you must feel rhythm. Nobody sat down and taught the model geography or code or sarcasm. They gave it an ocean of human text and one relentless task. Guess what comes next. And it turns out that understanding the world is simply the cheapest way to get good at that task. The intelligence was not programmed in, it was the byproduct of prediction, squeezed out under enormous pressure. So where does all that live? Not in files you could open. Inside the model are billions of numbers, called parameters or weights. During training, they start random and get nudged again and again until the model guesses better. That is all the knowledge is. Not sentences stored somewhere, but a colossal set of dials, tuned until useful patterns emerge. Picture it like this. Imagine reading 1,000,000 books, then burning every one. You could quote almost none of it, but you would still know how stories work, what cities are capitals, and how an argument is built. That residue, that compression, is what the model actually contains. And once you see it this way, the weird behavior everyone complains about suddenly makes complete sense. Take hallucination, when the model states something false with total confidence. People assume it malfunctioned. It did not. It did precisely what it always does, produce a plausible continuation. A true fact and a convincing invention feel identical from the inside because there is no checking step. The dials often do hold the right answer, but nothing in the machine pauses to verify the guess against them. There is only ever the next guess. It is not lying to you. Lying requires knowing the truth. Two speech bubbles side by side that look exactly the same, one labeled true and one invented, with the black box between them blindfolded, unable to tell them apart. And the same lens explains everything else rapid fire. Why does it not know about last week? The dials were tuned at a moment in the past, then frozen, so its world simply stops there. Why a different answer when you ask twice? It does not always take the top scoring word. It samples from the best few, and that pinch of randomness is what makes it feel creative instead of robotic. A wall of dials with a calendar stamped on it, frozen at a past date behind glass, next to a pair of dice choosing between the top 3 word candidates on a small podium. And why can it write a gorgeous essay yet stumble on multiplying 2 huge numbers? Because an essay forgives, and arithmetic does not. Exact calculation demands every single digit be perfect, and a machine built to produce the most plausible continuation approximates instead of executes, which is why serious systems hand that job to an actual calculator, something we will come back to later in the series, along with the newer trick of letting the model write out its thinking step by step before it answers. The same black box politely passing a long multiplication problem to a small pocket calculator beside it, while keeping a beautiful half-written essay for itself. Now, an honest note. Some systems you use do look things up. They bolt the search engine or your documents onto the model and feed the results in as extra text. That is a real technique with its own episode later. But underneath, the model itself is still doing only one thing: guessing what comes next. So here's the big picture, worth carrying with you. A large language model is not a knowledge machine. It is a plausibility machine, astonishing at producing text that fits, with no built-in step that checks what is true. That one sentence explains its brilliance and its failures at once, and it tells you exactly how to work with it. Trust it for shape, structure, language, and ideas. Verify it for facts. It is not a librarian. It is the most sophisticated pattern of language humanity has ever built. The same black box from the opening, but now with its front panel removed, revealing the wall of dials inside and a small sign that reads, "Plausibility machine, not a knowledge machine." But we skipped something enormous. Those billions of dials did not tune themselves. Nobody set them by hand, and nobody could. So how does a machine read most of what humans have ever written and slowly turn it into numbers? That's next time, when we open up training and find out what the model is really reading when it reads.